This is Algebra 2, Lesson 10-3. Today's date is Monday, March 30th, 2020. Our objective today is to apply the advanced ninja star to higher degree polynomials. So we are on Lesson 10-3, using the structure to factor polynomials. So everything kind of stems from the advanced ninja star, so I thought I'd review it. You'll be using it a lot tomorrow as well, and today is kind of our review day to get ready for Lesson 10-4. So if I have this sort of it's called a quadratic trinomial, quadratic because this is x squared, and trinomial because there are three of these terms. I have to first factor out the greatest common factor. That's always my first step, and because this is a 2 and a 5, those are co-prime, meaning there's nothing that I can factor out in terms of the coefficients, and there's no x in this last term. It's a constant term, which means the greatest common factor for all three of these terms is 1. I can't factor anything else out of it. So after doing GCF, I am now going to do Advanced Ninja Star. So again, Advanced Ninja Star looks like this, where I have the line in between. In the bottom, I have -5. In the top, I have this -12 times 2 to get -24 in the top. Again, top left and top right is going to be 2x and 2x. So I'm kind of taking this leading, it's not a coefficient, but it's kind of this first term, but I'm dividing this number by 2. So 2 divided by 2 is 1, so this is going to be 2x and 2x. All right, so from there, now I'm asking what two numbers first multiply to -24 and then also add to -5. So I'm going to start going through my factors of 24. 1 and 24. Okay, that doesn't get 5. 2 and 12. No, it doesn't get to 5. 3 and 8. Okay, I can see 3 and 8 somehow getting to 5, so I'm going to just write down 3 and 8. And then from here, I'm going to figure out which one of these is negative, because I somehow have to get a -5, so the bigger must be negative. So -8, and there we go. -8 times 3 is indeed -24, and -8 plus 3 is indeed -5. So I've solved this, but again, the next step for the procedure for Advanced Ninja Star is to treat these both like fractions where I need to reduce. So in terms of this left fraction, 2x over 3, I can't reduce that. But this right fraction I can reduce. I can divide the top and bottom by 2. That's its greatest common factor. So if I divide the top by 2, I'm left with x. If I divide -8 by 2, I'm left with -4. And now I have reduced the fraction. So I can write my final answer as 2x plus 3, and that's coming from this right-hand side, or sorry, the left-hand side of our ninja star. And then our right-hand side is x minus 4. So this is times the quantity of x minus 4. That is Advanced Ninja Star. If you ever need to check your work, go ahead and multiply these back together. You can either use FOIL, you can use a box method, or whatever method that you want. All right, so example number 1. Now we're kind of advancing Ninja Star. We're advancing Advanced Ninja Star. We're doing the next harder step. So how do I do that? It's like, oh man, that's a power of 6. That's not a power of 2. It's the same thing. Remember up here I said in the top right and top left I have to do this number divided by 2. Well, now the top left and top right is going to be 10x to the power of 3. Another way of thinking of it is it's the middle term in terms of the degree of your variable. So again, it's going to be Advanced Ninja Star, but I always need to check the greatest common factor. So 10, 13, and 3. Okay, those are all co-prime, and there's no x here, so I can't factor out any variables. Okay, so GCF check, I can't do it, but let's go ahead and do Advanced Ninja Star now. Advanced Ninja Star looks a little bit different now. Oop, that's not a good line. There's a good line. Again, my top is going to be 10 times -3 to get -30, -30, and my bottom is going to be -13. -13. Now, this is the change. This is not 10x and 10x. That is slightly incorrect. I need to divide this power by 2, and I get 3. 3. And again, another way of looking at it is you just take this degree term. It's always going to be that middle term, x to the power of 3. Okay, now we've set up our new type of Advanced Ninja Star, and it's going to be the same question. What times what is -3? What plus what is -13? Let's go through all the factors. 1 and 30. No. 2 and 15. Ooh, 2 and 15 might work. So if I try 2 and 15, which one would be negative? It would have to be a -15. I'll make those go away. And that works. Okay, so 2 times -15 is -30, and 2 plus -15 is -13. Now, the next step is still the same. Everything else is still the same. I'm going to simplify my Ninja Star, so I'm going to divide the top by 2, or the left by 2, and I'm going to get 5x cubed over 1. I'm going to divide the right-hand side, the top and bottom, by 5, and I'm going to get 2x to the power of 3 and negative 3. So I've reduced the fractions, and I'm going to go ahead and write my final answer as 5x to the power of 3 plus 1 times the quantity of 2x to the power of 3 minus 3. And a good kind of just a quick way to check, of course the full way to check is to FOIL these back out, and you should exactly get what you started with. But a good check is, do these last numbers multiply to the last number? Or do these first two numbers multiply to the first number? The middle term is a little bit harder to do, but I'm sure a lot of people can still do it in their heads. But that's how you factor example number 1, and you'll see a few types like that on the test. All right, so on to example number 2. Example number 2 is still advanced ninja star, but it looks different. Like, okay, first you see, okay, 25x squared, that looks the same as some number x squared, but now the difference is, wait, two variables, x and y? Wait, a variable at the very end? Yeah, you're kind of mixing this variable with this variable in the center, so that can happen. Let's see what happens. So advanced ninja star, you're going to set it up very similarly. So it's going to be the top times the top is going to be 25 times 16, which is a big number, and I'm sorry that that's a big number. There is a shortcut to this, and I'll go over that really quickly at the very end. So I'm going to do 25 times 16, which is 400. 400. And in the very bottom, I'm going to put this negative 40. Negative 40. In the next step is basically the same thing. So I'm taking 25x squared, again, dividing this 2 by 2, and I get just x. So top left and top right are still 25x and 25x. And you might be thinking, wait, shouldn't I have to do something with that 16? Yes, if you're using the shortcut, but for our advanced ninja star, you can kind of ignore it, and it should still work out. So the next question is, what times what is 400, and what plus what is negative 40? The cool thing is, whenever you have some sort of problem that is a square here and a square here, for at least the homework tonight, this will always have the same number here and here, because it's a perfect square. That's the definition of what's happening here. So what does that mean? Well, what times what is 400? And that might be harder, but what plus itself is negative 40? Well, negative 20 plus negative 20 is negative 40, and you can check it also. Negative 20 times negative 20 is 400. And that's my cool hint to you. So like, these two numbers are going to be the same if if the first term and the last term are perfect squares. So when I'm doing that, I still need to simplify my fractions. So divide the top and bottom by 5 here, and that's going to be 5. Divide negative 20 by 5, I get negative 4. And the right-hand side is going to be exactly the same. It's going to be 5x and negative 4. The one extra step that you're going to have to do is, because we have a y at the very end, you still need a y here. So this is the one extra step, I suppose, which is this y needs to come to the very bottom. So this is going to be a 4y and 4y. And then we can write our final answer. So this is going to be 5x minus 4y times 5x minus 4y. And another way of writing that is 5x minus 4y, that quantity squared. And that's the type of answer that Khan Academy is expecting you to be able to write. I should leave that box. All right, and then I promised you a shortcut. So the shortcut is, if you ever see a problem that has a square here and a square here, at least for the homework tonight, you can just take the square root of that term, the square root of this term, put them in the first spot, the second spot, and then copy down this middle sign for the middle. If you just do those 3 steps, you're done. But again, I don't like just teaching you guys a procedure that you memorize and you don't understand where it comes from. Using the advanced ninja star still makes me cringe a little bit because it doesn't teach you the full process, but it's good enough to see where everything comes from. And finally, example number 3. It looks like a difference of squares, and it is. I mean, 81 is a square, 25 is a square. Technically speaking, a to the power of 10 is a square, even though b squared is very clearly a square, because you're literally saying b squared. So a to the power of 10, if I'm taking the square root of that, that's using rules of exponents. Let me show you what's going to happen here. The square root of a to the power of 10 is the equivalent of saying a to the power of 10, all of this to the power of 1/2, because a square root, this right here, is a 1/2 power. And then a power to a power means I'm multiplying those. This is equal to a to the power of 10 times 1/2, which is equal to a to the power of 5. Another way of saying that is whenever I'm trying to take the square root, I really just take half of that exponent. So why am I taking the square root? Well, this is a difference of squares. The difference of squares, the quick shortcut to doing that is taking the square root of the first and the square root of the last. Very similar to what we did up here, but I'm going to show you the long way first. I should have shown you the long way first to begin with. You use Advanced Ninja Star. Everything is coming from Advanced Ninja Star. Advanced Ninja Star needs 3 terms. I'm only having 2 terms here, which means I need to say that this is 81a to the power of 10 minus 0 something, or plus 0 something, and then minus 25b squared. So there is a middle term, and it's technically 0ab, I suppose, but 0 is fine, which means that this bottom coefficient is 0. The top is 81 times 25, which is ginormous. 81 times 25, 2025. 2025. So it does come from Advanced Ninja Star, but it's almost useless at this point because there's a quick shortcut, even when you get to this point in Advanced Ninja Star. Again, you want to put your 81a now to the power of 5. You always divide this number by 2. 81 to the power, 81a to the power of 5. And then I have to ask myself, what times what is 2025? Which is equivalent of saying x times x. What times itself is equal to 2025, which is saying x squared is equal to 2025. And therefore, if I just take the square root of that, 2025, then I'll get my answer. And again, I'll pull up my Spotlight search. SQRT, square root of 2025 is 45. So I come down here and say that is equal to 45 and 45. All right, so I have to reduce these numbers. Again, I have to take kind of the square root of this term and put it in the bottom. I didn't clearly do that down here. I just said just take that y and put it down there to make it make sense. I'm really taking the square root of this term and putting it down here. So the square root is b, the square root is b, and then reduce these fractions. So reducing this fraction, divide the top and bottom by 9, and I get 9. And then still a to the power of 5. Divide 45 by 9, and I get 5b. And then the same thing on the left-hand side. Ooh, hold on. I made a mistake. If you can catch that mistake, please log it in your extra credit trackers if you still have them. 45 plus 45 does not equal 0. And also, there was another mistake. That mistake is that I meant to multiply negative 25 times 81, and I got a positive 225, so I should have got a negative 2025. I'm saying it correctly now, which means one of these needs to be a negative, a negative 45. I'm just going to make that one randomly negative, which means this is going to be a negative 5 here. And then on the left-hand side, everywhere in the room, this is going to be 9a to the power of 5 divided by positive 5. And then, of course, over here, I already calculated that. I just didn't write it down. So our final answer here is 9a to the power of 5 plus 5 and 9a to the power of 5 minus 5. We have a conjugate pair. Again, the shortcutting method is very similar to the last one, where you take the square root of the first. Square root of 81 is 9. Square root of a to the power of 10 is a to the power of 5. Take the square root of the last. And if I'm only having 2 terms, then it's going to be a conjugate pair. If I have 3 terms, then I need to square it and then copy down the middle sign. So I know that those shortcuts were in words, but if everything fails, just use Advanced Ninja Star and it will work out. There's just a few extra steps, like moving this b down to the bottom or dividing this term here by 2 to put it in the top. Aside from that, and I guess sometimes the bottom too. Aside from that, that's our notes 10-3. I'll see you guys tomorrow.